Alright, today I'm going to teach you guys how to solve trigonometric equations in polynomial forms. So, before we begin, just a few things to remember. Trigonometric identities, our Pythagorean, opposite angle, etc., all those. Remember those because you're going to use those to solve. It'll be kind of like what Sam showed us with the proofs, just find ways to simplify and get them in terms of functions. You also remember your unit circle and what functions are positive and negative where for your answers, because that's pretty important. And then our notation. If you see an equation and it ends with 0 is less than or equal to x is less than or equal to 2 pi, basically if x is between 0 and 2 pi, then you're good, you just write your answers down. But if it doesn't say that, you have to add plus pi n to whatever you get to ensure that you cover all the possible answers for that question. So, how should we solve them? I'm going to break it down into 3 basic steps that you guys should know, because if you use these, then it's foolproof. So, first step to remember, set it equal to 0 if you can. This lets us factor to solve and possibly get multiple answers. And you want to pretty much do this as early as possible to make sure that you don't eliminate any possible answers, but I'll go into that later. You also want to get everything in terms of one function, as long as that makes it as easier, because if you have it in one function, you can simplify, factor, and eventually get your answer. Third, you want to use your inverse functions to solve. This is pretty straightforward. You just, once you get it equal to a number that you can solve, you do an inverse function to get your answer. So, to demonstrate these 3 things, I'm going to use the equation tangent squared of x plus 2 secant x over cosecant x is equal to -1 in the interval of x is between 0 and 2 pi. So our first step is to set it equal to 0. So we just bring the -1 over, and it's plus 1. Next, we're going to get it in terms of one trig function. So do you guys have any idea about how we would get this in terms of one trig function?
Like sine cosine, or just like
Just the secant over cosecant and the tangent. How would we get this to be all tangent or all secant or all cosecant? Do you guys have any idea?
Well, isn't that secant over cosecant like cotangent?
It's equal to tangent.
Tangent? Okay, there it is.
Yeah, so we change this to tangent, and voila, tangent squared x plus 2 tangent of x plus 1 equals 0. So step 3, we're going to simplify and use our functions to get our final answer. So for this particular one, we're going to factor it, because if you see the pattern where the tangent squared plus 2 tangent plus 1, do you guys know what we could factor this into?
x plus 1 tangent.
Tangent plus 1, as the name said. So we bring that down. It's tangent plus 1 equals 0. So now that will allow us to solve. This, of course, these are the same things, so we only need one of them. So tangent of x plus 1 is equal to 0. So now we just bring the 1 to the other side, and we're pretty much good. We have one more step left, and that's to use the inverse functions to solve. So all we do, here it is, inverse tangent of -1 is equal to x. And our final answer is 3 pi over 4 and 7 pi over 4. So they're basically regular polynomials. You just solve them using trigonometric identities, etc. So these rules are great. They pretty much work every time, but you won't always need to use all 3. So, for example, they don't always need to be put in terms of one function. Sometimes it's easier not to do that. A good example is this equation right here. We have sine squared x times cosine x minus 2 cosine of x equals 0. Now we could change that sine squared into a 1 minus cosine x, cosine squared x, but that would make things more complicated. There's a much easier way to solve this, actually. All we do is factor out a cosine of x, and we get cosine of x times sine squared minus 2 is equal to 0. So now we have 2 different things that equal 0, or could equal 0. So to get our answers, we set them both to 0, cosine of x is equal to 0, and sine squared of x minus 2 is 0. Then if we simplify that more, we do the inverse cosine of 0 over here, because we don't have anything else to move around. And over here, we're going to move the 2 to the other side, and then we're going to square root it to get the squared off of the sine. And finally, we get x is equal to 90 and 270. And then over here, we get x is equal to the inverse sine of plus or minus the square root of 2. Now, if you guys remember, no value of sine can be greater than 1. So this gives us no answer, no solution. So our final answer is 90 and 270. And we just did that without getting it in terms of one function. So just keep that in mind. And also the order matters. The way that you go through these steps that I've taught you is important because of one example which I'm going to show you now. So let's look at this one. Tangent of x times sine squared of x is equal to 2 times tangent of x. Now, there's one way that we could get this in terms of one function. What do you guys think it is? How could we get rid of the tangents? We could divide them, right? Yeah. Sorry, I interrupted. So if we could divide the tangents out, right? Cross them out, now we just get sine squared of x is equal to 2. And that would get us sine of x is plus or minus the square root of 2, which is no answer. So that's not good. Like, we don't want that. That's wrong. There's a way you can get more answers for this. And the way to do it is to go back to the beginning, and instead of trying to get it in terms of one function, we want to do the first step that I told you, which is to set it equal to 0. So we bring this 2 tangent to the other side, and now we're good. So now we can start to solve it. Now we can factor out a tangent x, and it's tangent of x times sine squared of x minus 2 is 0. Now look, we have two things that equal 0, tangent of x and sine squared of x minus 2. So we already know that this doesn't give us an answer, so we'll just focus on this one. Tangent of x is equal to 0, and if we solve that, then x is equal to 0, x is equal to pi, and x equals to 2 pi. So, just keep that in mind. Always set it to 0 first if you can. That's the right way. So just to recap quickly, so you guys remember the 3 steps: set it equal to 0, get it in terms of one function, and then use inverse functions to solve. Then there are some exceptions though. You always want to set it to 0 first, the exception is that you don't always have to get it in terms of one trig function if it's easier to do another way. And then solve everything in order like we just said. Don't get ahead of yourself, set it equal to 0, and then simplify it. And that's all.